All right, so to get started, let's head over to our browser and type chuks.org. Then we head to the documentation section and move down to concurrency. Yeah, so Chuks has first class concurrency built into the language, and there are two complementary primitives to this, which is the async await and spawn, right? So the async await is for non blocking IO bound work, while the spawn is for CPU bound parallel work. So both async and spawn creates real lightweight threads under the hood. The difference is when they are used and what they express, right? So the async and wait mark a function as asynchronous, right? And calling it always runs in a concurrent lightweight thread and returns a task. So you use the await keyword to get the result. And for the spawn, this runs any function, whether an asynchronous function or none, in a parallel lightweight thread. And it also returns a task, right? So let's do a little demonstration of this. If I click this here, I'll create a new file called concurrency.chuks. And so I'll paste this here and I'll just print this function, which is fetch user ID. I'll just pass in 12. And over here, I run this using the chuks run command. Navigate to the file. So this returns task pending. So probably I need to await it. And so we have the results user 2, right? So let's discuss about what we call sequential asynchronous execution. So what this means is that the first asynchronous action executes and completes before the second one starts, right? So let's demonstrate that using this basic function. So let's say I have an async function called fetch name, and this returns a task because every asynchronous action in Chuks returns a task, and this returns a task of type string. Here I'm returning return Chuks. Okay, I have another function, async function called fetch age, and this returns a task of integer. Then I'll return 20. Then here I'll create a variable called name of type string and await a call to fetch name, right? And also create a variable called age of type int and await fetch age, right? So let's print these two variables. I will do name is age, right? So if we run this, so you have Chuks is 20. Yeah, so I'll just comment this out. Yeah, so Chuks is 20, right? So in the next section, we'll discuss about concurrent asynchronous action. right? So remember, this is sequential asynchronous action. So we discuss about concurrent asynchronous for action or function, right? Yeah. Spawn helps you to run CPU intensive operations in different threads, right? So spawn is for um, parallel computation in Chuks, right? So to demonstrate that, um, let me create a function called is prime. So this accepts n of type integer and bool, boolean, right? It returns a boolean. So what this thing does is it actually checks any value that comes in here, whether is a prime or not. So first I need to do is if n is less than 2, right? So return false, and I'll create a variable called I of type int, and I'll assign 2 to it, then do a while loop of I multiplied by I less than or equal to n. So here I will check if n modulo I is equal to 0. If that is equal to 0, I'll return false. Else I will now be I plus 1, right? So increment that, and over here I'll return true. Then down here I will create another function called count primes. Okay, so this will have start of int and end of int, right? And this will return an integer. Here I'll create a count of type int and assign 0 to it. Then I will create a variable called I of type int, and this will be the start. Then I'll enter a while loop. If I is less than end, right? Then I'll check if, sorry, while I is less than end, then I'll check if is prime of I. Then count will now be count plus 1. Then over here I will increment the value of I by 1 and return count. So I have this function to count the primes, and the next section is now to run this in parallel, right? So to do that, I'll just write a comment here. So we need to fan this out in for parallel think that should be parallel. Yeah, parallel workers. So to do that, I'll create a var called task1. So this is a task that's task of type int. Here I will spawn this count primes and pass 0 to 250,000. Right, so just copy this, and this will be tax 2, 3, 4. Then from 250 to 500, from 500 to 750, from 750 to 1 million. Okay, so over here I will collect the results, right? Results. So to do that, I'll create a variable called total of type int, and I'll await task1 2, 3, 4, task2, task3, and task4, right? And here I will print total primes. Total primes is so I'll cast this to a string, because we said that the total is of type int, so with string I'm casting it to string. And if I run this, it's executing, and that's the result, total primes, right? So what is actually happening here is that we are calling all this in parallel, right? And we are collecting the results using await, right? So we can also use tax.all to await all the results. Yeah, so this is basically it for parallel execution. We also have more implementations of it, which we can discuss in the next video. Bye for now.